Hey folks, okay, I wanted to get into a little bit of Lab 1 this time around. So far, week 1, we've only had a very limited bit of Lisp to play with so far. What I'm going to do in this particular session is to go through a little bit of basics of using Lisp interactively, using Lisp in scripts, and just experimenting a bit with it, and hopefully everybody gets a chance to get familiar with just the basic syntax and use of Lisp. And then I'll talk about the lab itself and let folks experiment some. I think what I'll do is save the second week's video for getting into more of the gory details of the current lab. I will talk about the requirements for the lab in this week's session, but we won't get into too many of the programming details. We'll save that for next week when you've seen more of Lisp. Okay, so that's the general idea. Again, this first lab, you've got 2 weeks for the labs roughly. And for this first one, we just want to get used to the fundamentals of programming in Lisp. And so what I want to start off with is perhaps just take a couple of moments to play with it interactively. So the interpreter for Lisp that we're going to be using is called GCL. So if you just type in GCL and hit enter, it will fire it up. And the way the interpreter works is basically you type in a command, the interpreter evaluates it and spits back the result. So it's going to treat everything as either a function call that it has to evaluate or just simply as a piece of data. So if I just type in something like 27, it's just going to come back and say, yeah, the value of 27 is 27. Or if I type in the string foo, it's going to say, okay, the value of string foo is string foo. If I type in just a name, X or something like that, it's going to go through and treat that as a variable, but it doesn't know anything about X yet. So it's going to come back and tell me that it's got this unbound variable, essentially a variable that isn't tied to anything, a variable that isn't declared if you're thinking in kind of C-ish or C++-ish terms. But it gives us this error message. One of the things it's done here is dropped us into its debugging mode. So it'll give you a variety of options at the bottom here that says, 1 to return to this debugging level, or 2 to return to this, or one of those options is going to be to return to the top level, which is basically getting us back into normal mode. So if you see that, look for the one that says return to the top level. In this case, it's the only one. Enter the number for it, and we're back at our regular Lisp interpreter. Let's see. So I just wanted to make sure folks play with this a little bit. Remember that in Lisp, everything that isn't a simple piece of data is a function call. And in Lisp syntax, the name of the function is the first thing inside the brackets. So if I want to add 1 and 2, it's plus 1, 2 in the brackets. If I want to take the minimum of 10, 20, and 30, then the name of the function goes, again, inside the brackets. So that's one that's going to be an inevitable typo for lots of us, moving back and forth between other programming languages where it's min and then the opening bracket and then the parameters, right? This is a syntax error that we're all going to make lots of times. Get used to it. But again, the idea is the first thing inside the brackets is the name of the function. And in this case, the smallest one is 10, so it gives us back that. It does mean that if you're, you can go through and nest function calls. So let's say I want to take the sum of 10 times 20 and something else. So we'll do the 10 times 20. So again, I want to take the sum of the first thing, right? So the function's going to evaluate return 200, I guess, in this case. And I don't know, 5 minus 4 or something like that. So the operator comes first, the minus, 5, 4, and we get all our brackets to match up. So we're saying add together the result of 10 times 20 and 5 minus 4. All right, so we get our 201 coming out. So again, you can play with this stuff. Some of the common errors that you're going to run into are things like, we try, it's common for folks to forget that the operators have to come first. So you try something like this, and Lisp is going to yell at us. And what's happening is, it sees the opening bracket, and so the next thing it sees is supposed to be the name of the function. So it sees 1, and it goes, 1 isn't a function, and so it complains, and, it's saying it saw this data value 1 when it was expecting a function. So that's what that error message is trying to tell you. And again, we'll get out of our debugging mode here. Or, again, you do things like, use a regular C-style syntax, and it starts yelling at you again, and it sees min outside brackets and thinks that's got to be a variable name, and it tells you, I don't know anything about a variable name min. So again, things that you're going to run across fairly commonly. You will get more used to going, oh yeah, I remember now, it goes inside. But again, just things to watch out for when you're playing with this stuff. Let's see, what are some of the other things I wanted to take a boo at? The input function is called read. So read will read one thing that the user types in and return it. So it's waiting for me to type in something. I don't know, I type in 200 and it says, okay, the value of read was 200. Read's pretty good at figuring out what kind of values you're entering. So if the user enters a string, it'll grab the string for you. If they enter an integer, it'll grab the integer. If they enter a float, it'll grab the float. If they enter a list, it'll grab the list. It's pretty good at figuring out what kind of data structure the user entered, as long as it's something that Lisp can actually interpret. All right, we can go through and create variables. So let's create a variable x and initialize it to 10. So it tells me that it's created x. Maybe I create another one, y, and let's initialize it to some value that the user enters. So I'll stick a 20 in there. And so now if I type in x, it's going to tell me, okay, x is 10. If I type in y, it's going to tell me y is 20. We've got the setf function that's kind of like an assignment. So let's set x to 12 this time. Or let's set x to foo. So the data types are dynamic, right? So if I type in x, it's foo now. So you don't have any concept of a variable having a specific data type associated with it. It's just whatever the type is for the value that's in that variable right now. Let's see, again, the print function that we're going to use is called format. It takes a single true-false, well, not really true-false, but we'll throw in a true or false value as the first parameter, telling it whether we want us to actually display the string that's coming up or whether we want it to return the string that's coming up. I want it to display, so I'm going to pass a true and say the value of x is, and if you're used to things like printf in C or C++, where you've got a placeholder for a value that's going to appear in the string, we've got the same sort of idea in Lisp. It's just it looks a little different. Tilde A is for your placeholder. And I'm going to throw in a new line, which is our tilde% in Lisp. So again, syntactically a little unusual compared to what we're used to, but that's basically the \n, if you like, the new line. And then we want it to stick the value of x in there, so we'll throw x in. And so it tells me the value of x is foo. And then it gives me, so this is what's printing out, and then the second thing is the value that the format statement is returning. So if I just do my format like this, it prints out the message and returns a nil. If I try the same thing with a nil there as my parameter, it's going to return the string instead of printing it out. All right, so it gives me back that string that's got, the value of x is foo and then the new line. Alrighty, and if you ever want to get out of the interpreter, it's just quit. Again, as a function call. So have a bit of a play with Lisp. Oh, actually, let's throw in one more thing. One of the things that you're going to do a lot is type checking in Lisp. So again, there's a variety of the different functions that you've seen for checking if something's an integer. Is 10 an integer? It says yes. Is foo an integer? It says no. And again, remember t for true, nil for false. So there's a whole slew of these things, right? Check if something's a real. Check if something's irrational. Check if something's a string. Oops, I missed my P on that, but check if something's a string. Right, so all sorts of different type checking functions available in there. All right. Okay, maybe a little bit about the mechanics of the lab this time around. Again, for all of our labs, we're going to be using our usual Git submission process for getting the lab, for doing that SSH fork and the clone, and then adds, commits, and pushes to submit. So I'm just going to run through that process basically once. I'm assuming most of you have run across this a fair number of times in the past by now. But again, the idea is, I've got my CSCI 330 directory that I'm sitting in right now. And what I'm going to do is just check and see if I can fork this beastie. So for this one, it's CSCI 330 lab 1, and so that's going off to the server, grabbing the CSCI 330 lab 1 repository, and I want to store it in MySpace on the server. So it's going to be under 330, under my username, and still called lab 1. So that I'll go off and create the space on the server side. And then I'm going to try cloning it locally so I can actually work on it here. So it's the git clone CSCI, the course. I want to clone mine, and it's lab 1. And so that's gone off and cloned my lab 1 directory or repository. And if you grab it, you'll find that there's a couple of files already created in there. The ones that we're interested in are lab1 fun and lab1 script, and they're both using the .cl extension for Common Lisp. And the lab1 script is actually an executable. So you can try running the lab1 script right now. It won't do a whole lot. I think it says something like, oh, pardon me, it's got a, it does have some content to it. Let's see, so we've got this simple script that exists. I'll talk about the content in just a second, but we've got these two Lisp files that we want to be able to play with. So for this lab, we've got, let me open up the lab 1 script here. We've got partially completed files here. Both of these .cl files are partially complete, and they each have comments in them describing what should take place. So you're going to go through and edit these beasties. So I guess we'll throw our, throw our name in here. And again, there's comments as to what the script is supposed to be doing. So, and remember the semicolon for firing up a one-line comment in Lisp. So what it's doing is loading that other Lisp file. So that other Lisp file's got a bunch of function definitions in it. And this is basically like a hash include in C++. So it's loading this, and then I've just got a bunch of sort of simple sample Lisp statements in here, just creating a couple of variables and calling a couple of the functions that are in the other one. Again, just to kind of demo what's going on. You'll get rid of this stuff and replace it with your own code that carries out the instructions in the script here. And basically what the script is doing is related to getting dates from the user in the form of a year and a Julian date. So, like 2022, and then an integer that's, 1 to 365 or 1 to 366 for a leap year, telling you what day of the year it is numerically. And then it's printing out a bunch of information based on that. So this script, again, I've dictated what it's supposed to be doing, and it's making a bunch of calls to functions that are provided in that other script. So let's take a look at that lab1fun.cl. And so for this one, again, there's a whole bunch of different Lisp functions that have been defined. GetInt function and a few parameters it takes, an error message function and the one parameter it takes. Those two have actually been completed, so those two are done. But then there's another 4 or 5 afterwards where there are comments explaining what the function is supposed to do. We've got the definition of the function with the names and the parameter list, but basically just empty bodies. So you're going to be replacing the body with stuff that makes it actually do whatever the comments say it's supposed to do. So that's kind of the idea for the lab. Now, this week when you're just getting fired up with Lisp, probably most of what you're going to be doing is just firing up maybe a few of the the steps that are listed in that lab1 script.cl, and maybe putting simple portions of some of the bodies in the lab1 functions. We'll get into more of the useful code for doing the rest of it in next week's lectures and next week's labs. But again, get as far as you can, and you can always take a look at the material for next week's lab or next week's lab session as well if you're interested in plowing on ahead and getting into some of the material for next week's lectures. If you're interested in plowing ahead and getting a bit of a jump start on this, none of the code is too bad. Again, it's meant to be primarily a chance to get a little bit familiar with Lisp. So it's the usual idea when we're playing with Git. If you go through and change something, then you can use git status to see what the current state of things it happens to be. So I've modified my lab1.script. So if I was going to submit this now, I'd do my git add lab1 script.cl to make sure it's remembered my changes. I git commit. I'm going to just use the -m for a quick commit message here, and I don't know, what did I do? I put in my name. And if I wanted to push, it's just a git push, and that'll send it back server side. And again, you can push as often as you like. Just remember, before the lab deadline, do your add for the 2.cls, do your adds for the 2.cls, do your commit, and do your push. Alrighty, and again, you can do the git status, and hopefully if everything's up to date, then it tells me, yeah, you're up to date with Origin Master, working tree is clean, you've got nothing left to add or commit, you've pushed. So as far as the mechanics go, that's pretty much the idea. So I will mostly leave things there. If you do want to get started on playing with the some of the error checking and things that are involved in the different functions in the lab, then you're probably going to want to work with, let's say, some of the functions along the lines of ifs. So if is a function, right, in Lisp. It takes a condition to check. So let's create a couple of variables here. Let's create x is 10 and y is 20. And let's try an if. So we'll say, let's get an if statement here that just returns the smaller of the two. So again, an if statement is a function. It's going to return a value. Its parameters are the condition it's supposed to be checking. So let's see if x is less than y. And then the two things it's supposed to do, the thing for the true case and the thing for the false case. So if x is less than y, we want it to return x. Otherwise, we want it to return y. All right, and so in this case, hopefully it's going to give me back the 10. Yeah. And if you want your if statement to actually do something rather than more complex than just simply returning a single value, again, you could have function calls in here. So I could go through and say, okay, well, it's, I don't know, print out let's print out whichever one is smaller with a little bit of a message here. So if x is smaller, we'll say the smaller is x. And otherwise, we'll say, I don't know, the smaller is y, and print out the value of y. And end our format, and end our if, and give that a try. And so, yeah, sure enough, it prints out the smaller is x. So you can build up things along these lines. The one thing with the if statements is that, you've just got this single function call you can make for the true case, and a single function call you can make for the false case. If you want to test and do a bunch of steps, I'd recommend jumping to things like when, where you can say, okay, well, when x is less than y, you can do a whole bunch of things. So let's say format t, the smaller, or let's say x smaller, and print out its value. And we'll also say y larger, and print out its value. So you can do multiple things inside a when. And the idea is, if this is essentially saying if x is less than y, do all of these things, right? So we should get both of those coming out. And it returns the value of whatever the last statement was. So in this case, the return value of a format is just nil. And similarly, there's an unless. So unless, let's flip it around here. So unless y is less than x. So this is saying if this isn't true, do whatever's in here. So I'm going to be lazier here. Right, so in this case, y is less than x is false, so it does the whatever statements are inside the unless block. And so there are a whole slew of these things that you can play with. What we'll do in the session for next week's labs is get into const, since that's probably the most useful one for this. Recap recursion a little bit, which should actually be pretty intuitive by that point. And we'll go over some of the defun stuff, since you will have seen that by now for function definitions. All right, I will leave it there for now and let you have a play with Lisp.